My dear NEET warriors, let me know if I'm quickly audible and visible to all of you. And this is your Captain Shreyas, your physics master teacher going live on the Vedantu NEET English channel. And here we are today to go on to the next part of current electricity. We saw all the current parameters in the previous session. I had to put it up over here because I think the stream got ended abruptly. So current, resistance, drift speed, Ohm's law, mobility, everything we discussed, all the parameters in the previous session, please watch it. And today we are going on to the combination of resistors, the combination of cells, series, parallel, and some disguised forms, and also infinite resistors in combination. Kirchhoff's laws, the current law and the voltage law, all of this very important, which will also lay the foundation for your next class. Good evening, Swetha. Welcome everyone, and please smash the like button because your support means a lot to me and the channel. This is your channel, remember, for all the students who not only want the best content and quality teachers but also in English. Okay, so make sure you support it. Okay, it's your channel. Good evening, Suguna. Good evening. So let's go completely focused now because it's a very um, little bit longer class. It will take me more than 2 hours for sure because a lot of concepts are there. It's going to be a heavy class and current electricity is also heavy. All right, ready, my dear students? Shall we begin? Subscribed, liked the video. All right, so let's begin, my dear students. Okay. All right, let's begin. Ready. Valid in 10th standard. Well, most likely, but still, it's my duty to recollect those concepts. When we say combination of resistors, what I mean is you might have a complex circuit, maybe like this, then like this, then maybe like this, and then maybe like this, and maybe something like this, okay, and then maybe something might go here, okay, like this, and like this, maybe something comes over here, and finally it comes over here. So maybe this could be your circuit which is there, and these are the 2 points from which the current will enter in and it will exit out. It's some network of resistors. This is some kind of network of resistors. You can always, no matter what kind of resistors, what combination it is, you can always convert this network of resistors into a single resistor, which is often called as the equivalent resistance or equivalent resistor. So between those 2 points, if you put this resistor instead of all these resistors together, you will see that the same current will flow as much current was flowing before, and whatever voltage difference was there, let's say some kind of voltage difference was there across this circuit, that same voltage difference will be there in this particular resistor also. So equivalent resistance is that resistance such that you can replace all the network of resistors into a single resistor, so that for the same voltage you get the same current flowing through it. It kind of makes sense. It's an equivalent. Instead of 10 people you have 1 person, instead of 10 things you have 1 thing. So that is equivalent. It behaves in the same way as those of the other things over here. Correct? Perfect. Now there are 2 major combinations which we'll start off with, but remember, you can have certain things which are neither series nor parallel. Yeah, a lot of people think the only 2 possibilities of resistors are series and parallel, but that is the basic type. There are many such combinations which are neither series nor parallel. Today, we are limiting ourselves only to series and parallel. Be it batteries, be it resistors. So, what if in the exam you get something which is neither series nor parallel? You might be wondering, how can it be neither series nor parallel? Just think about it, something like this. Maybe this one over here, this one over here, this one over here, like this, and maybe something like this over here, like this, and like this, something over here like this. This is neither series nor parallel. This is something weird. Okay, it cannot be really converted into a single series or parallel combination. Okay, it's something weird. So we'll talk about it in the next class when we learn Kirchhoff's laws. But today we are limiting to series and parallel. Okay, everybody clear about this? What we are limiting ourselves today to, and what is the next class all about? All right. So let's talk about first resistors in series. When we have resistors in series, so we have things like, say for example, this is one resistor, another resistor, one after the other. This is R1, this is R2, this is your Rnth resistor. I convert this into a single resistance which is called Rs. This Rs will be nothing but just R1 plus R2 plus like that till Rn, till the nth resistance. Just simple algebraic addition, nothing else. Just add the resistance, that is the equivalent resistance. Also, whatever current will flow in any of the resistors will be the same current through all of them, and not just that, also through the equivalent resistance. So the current in all the resistances is the same. So the I, which is nothing but the current is the same in all of them. It's the same current which is going to flow in all the resistors. But what is not same is very obvious now. It is the voltage. So if this is the voltage V across the equivalent resistance, it is also the total voltage across the entire set of resistors. But if you take individual resistance, like say for example this one, it might have voltage V1, this might have some voltage V2, and so on and so forth. The last resistance might have a voltage of Vn. If you add this V1, V2, V3 like that, all the voltages, what you get is the total voltage drop across the entire circuit. This has 2 volts, this has 3 volts, this has 1 volt, this has 7 volts. So all these things, 2, 3, 1, 7, etc. If you add them, if you add these voltages, you will get the net voltage drop. So the potential drops add. So the net voltage is the sum of each potential differences. This is another important thing regarding your series combination. This also leads me to another formula which we are going to talk about now. Let me put it over here. And this is also sometimes called as the potential divider formula. Which says that, say for example, you take any resistor, goddamn, doesn't matter. Let's say you take this resistor and you want to find the voltage V2, or you want to find the voltage V1, or you want to find the voltage Vn, you want to find the voltage V3, doesn't matter. Each of these voltages, or observe this, say for example V1, will be by Ohm's law current into that resistance. So it will be current multiplied by that resistance. This is plain and simple Ohm's law. Is that right? This is nothing but Ohm's law. What is that current? If you think carefully, you will realize this current is passing through all the resistors, also through the equivalent resistance. So think logically, this current is the total voltage by the total resistance. Isn't that right? This particular current which you see over here is nothing but the total voltage divided by the total resistance. The total resistance is nothing but R1 plus R2 like that till Rn. That is the total resistance. Oh, perfect. So therefore, V1 will be V divided by R1 plus R2 plus R3 like that. This R1 was there and this will be into R1. This is a very important formula. So this formula can help me figure out the voltage across any resistor. So same way we can say similarly, one can argue how much will V2 be equal to? V2 be equal to total voltage divided by R1 plus R2 plus like that till Rn. And the whole thing, because this is V2, you multiply it with R2. Same thing, you can say Vn will be, here you will have Rn and here you will multiply by the total voltage divided by R1 plus R2 like that till Rn. So you can figure out any voltage across any resistor. This formula for finding that voltage, this is called as the potential divider formula, right? So whatever formula you are seeing over here, this is called as the potential divider formula. Very, very important. Let me show you some examples on this. Then you will get some confidence, right? So let's do a question on this. Say for example, it says there is plus 20 volts over here and there is one resistance, another resistance, another resistance, and let's say this is, I don't know, minus 40 volts. Chumma, okay? This is one point, this is another point. Let's say this is 10 ohm, let's say this is 5 ohm, let's say this is 15 ohm, okay? Just I have taken some random values. Now, if somebody asks you, can you figure out what is the voltage across this 5 ohm resistance? They are asking you what is the voltage across this particular 5 ohm resistance. It can be alternatively said that, listen, I have put a voltmeter. Can you tell me what is the reading in this voltmeter? This is how the question can be framed. So what you will do, first of all, do you see all these three resistors are in series? Can you guys easily notice that 10 ohm, 5 ohm and your 15 ohm, all of them are basically in series combination. Yes, sir. Series combination. Perfect. Very good. Yes. So, very good. Yes. Awesome. Welcome. Welcome. Yeah. Now, look over here. If you notice, since all of them are in series combination and I want to find the voltage across any one resistor, I can definitely use this potential divider arrangement formula, isn't it, guys? I can definitely use this. So what do I need to do? I need to measure the total voltage across the combination divided by total resistance and multiply it with that specific resistance across which I need to find that voltage. So that particular reading will be, observe carefully, the total voltage divided by three resistors are there, R1 plus R2 plus R3 plus R3. And in this specific case, I want to find the voltage across resistance number 2. Okay. So let's start putting the values of R1, R2, R3, etc. So 10 plus 5 plus 15. 10 plus 5 plus 15. And we want to measure it across 5 ohm. What do you think is this value of V? Answer it in the chat box quickly. Everyone. Thank you so much, Praga. Can you guys quickly tell me what is that value of V? Everyone. Rama, Praga, Miss, Zoro, everyone. The Patels, Kevin. Come on, Unstoppable. Everyone. Gamer, Darshan, Dev, Archit. Yes, Aswin. Come on. Ali, TN, Ritik. Everyone. Come on. What do you think will that particular value be? Hi, through me. Yes. Man, I'm not on mute. I think you are on mute. Maybe check your headphone. Okay. I think I can see everything working finely. I get all the signals over here. Yes, lot of people are going to say, sir, 20. Wrong. Be careful. It is not 20. See, the voltage, this V is technically the voltage difference. It is the net potential difference. It is nothing but 20 minus 40, which is technically plus 40, which is nothing but 60 volts. So lot of students make that mistake. So this is 60. It's the voltage difference. This is 20, this is minus 40. V always stands for voltage difference. Keep that in mind in Ohm's law, etc. Yeah, many students made that mistake. Correct. So now, substituting that, we can definitely get the answer over here. So this is 60 divided by 10 plus 5, 15. 15 plus 15 is 30 and multiplied by 5. So 60 by 30 is 2. So 2 into 5, which will make it 10 volts. So the voltmeter reading will be nothing but 10 volts. As simple as that. Yeah? Yeah. Yes, Archit, I am from Pune originally. Correct. Very good. Yes, sir. I understood this voltage divider or potential divider formula, and I understood how to find the equivalent resistance also. Fair enough, guys. So, having said that, let's go on to the parallel combination now. Let's go on to the parallel combination. So, let's talk about resistors in parallel. Resistors in parallel. Resistors in parallel. Okay, so imagine something like this. This is one point and there are many branches like this. So the first resistance here, second over here, third, fourth, like that. These are n resistors, different branches. Again, they will all merge at the same point. Many such things are there, and this is the outlet. So let's say this is R1, this is R2, R3, like that. This will be Rn. Now, you want to merge this off, convert this off into a single resistance, which is just going to be, let's say, Rp over here. And notice one important thing, whatever current comes inside, it will definitely get distributed like this. So this will be I1, let's say this is I2, let's say this is IN. So that current is getting distributed, but if you replace it with one single resistor, then the same current will flow over here. Fair enough? So here the current gets distributed. So I can say that the current is distributed. The current is distributed in all the branches. So therefore, I can say that the original current will be nothing but I1 plus I2, like that till the nth current. So that is the first thing that I can notice over here. Not just that, I also notice that whether I measure the voltage across R1, R2, R3, R5, anything, or this, the voltages will be the same. Yeah, so whatever voltage drop will be there across these resistors is also across this resistor, and this voltage is same across all the resistor. So voltage is going to be the same for all resistors in parallel, for all the resistors which are going to be there in parallel. But remember, in series that was not the case, they were added. Yeah, the voltages were getting added. V1 plus V2 plus V3 was the total voltage. But here, that is not the scenario. It is the same for all. What about the equivalent resistance? Well, you use the reciprocal formula. You add the reciprocals of the resistance, not the resistors itself. So 1 by Rp will be 1 by R1 plus 1 by R2, like that till 1 by Rn. So you add the reciprocals in this case, right? So this is the formula for the same. Everyone till this point absolutely clear? Yeah. Sir, can the resistance is 0 in parallel sometimes? No. Why will resistor be 0? Because if you have some resistors, they will obviously give some resistance. It might become small, but it will definitely not be 0. Okay. One important thing is the equivalent resistance in parallel is always less than any of the resistors in the branch, in any of the branches, meaning that this particular RP is less than either R1 or let's say R2 or let's say R3 or Rn, any of them, if you take, yeah, it is always lesser than that. So if you have 5 ohm and 3 ohm, the equivalent will be lesser than 3 and lesser than 5 also. Okay, that is for parallel. But for series, that is not the case. As you can see right over here, the final resistance is definitely more than either R1 or R2 or even Rn, because you're adding all the resistors. So definitely it will be more than each of those resistances. Okay, that is for series. But for parallel, it is lesser than that. We can take a few examples to make you understand these things. Now, often you are given 2 resistors in parallel and then you have to quickly find the equivalent. See, when you have, let's say, same resistors in series versus same resistors in parallel, then it is very easy to find the equivalent. Like for this particular scenario, because they are in series, the equivalent resistance will be R plus R plus R, which is basically 3R. But over here, 1 by Rp will be 1 by R plus 1 by R plus 1 by R, which is 3 by R, but that is 1 divided by Rp. Therefore, Rp will be R divided by 3. So, in series, you can see the final resistance is definitely larger than any of them, and in parallel, it is definitely lesser than any of these resistors. So, when they are in series and all of them are same, just if there are 5 resistors, 5R. If there are 100 resistors, 100R. But in parallel, if there are 5 resistors, it will be R by 5. If it is 100 resistors, it will be R by 100. If there are 1000 resistors, it will be R by 1000. That's how it goes, assuming all of them are equal. Also, many times when the 2 resistors are not necessarily equal, something like this. Say for example, you have one resistor here and another resistor here. Maybe this is R1, let's say it is 3 ohm, and let's say this is R2, maybe let's say it is 6 ohm. Sorry, not series, my bad. Parallel I wanted. This is one resistor and this is another resistor. So R1, let's say it is 3 ohm and R2, let's say it is 6 ohm. So whenever such situation comes, see 1 by Rp is 1 by R1 plus 1 by R2, isn't it? So if you take the LCM, it will be R1, R2, correct? And this will be R1 plus R2 on the top, but this is the reciprocal of the final resistance. So Rp will be R1 multiplied by R2 divided by R1 plus R2. Now this formula is beneficial most of the times only when there are 2 resistors. Directly you can get the answer. So in this particular scenario, if I use that particular formula, the equivalent resistance will be R1 R2, that means 3 into 6 divided by R1 plus R2, that means 3 plus 6. So 6 3s are 18, 6 plus 3 is 9. So this will be 2 ohms. So I can easily get the equivalent resistance using this simplification, the special case formula. Everyone till this point absolutely clear? Yeah. We are going to do voltmeter, ammeters later on. Yeah, we are going to do that later on. Yeah, Rama, don't worry. Yes, perfect. Now, you need to keep in mind that sometimes it could be a combination of multiple things. Like for example, there is a resistor here, another resistor here. Let's say another resistor here, and maybe this. Sorry, maybe this is over here like this. And you have to find what is the equivalent resistance, assuming all of them are R, assuming all of them are the same. So whenever such a situation comes, always try to see if something is in series or in parallel and then start doing it. See over here, as you can see clearly, these two resistors are in parallel. So they are in parallel, and when same resistors are in parallel, the resistance will become R divided by the number of resistors. There were 2, so divide by 2. There are 3, divide by 3. The same logic we have used over here also. 3 resistors R by 3, 2 resistors R by 2, 100 resistors R by 100. So same thing I will apply over here. So obviously this circuit will break down now to a single resistor over here, and that would be basically your R by 2. That will be basically your R by 2. That is what has happened. Alright, so these two combine together into this one. Now these two are in series. Can you see that? These two resistors are definitely in series. So what can we do? We can just say, okay, these two, because they are in series, we can just add them. So it will be R plus R by 2, which is 3R by 2. Perfect. So if it is 3R by 2, I don't need two resistors anymore. I can just write down a single resistance whose value is 3R by 2. Okay, which is 3R by 2. Okay, but still not solved. One more thing is remaining, and that is this one, where these two resistors are side by side, two separate branches. So they are obviously in parallel. So we cannot just divide by 2. It's not possible because they are unequal. So R1, R2. So R1 multiplied by R2 divided by R1 plus R2. Okay, so what will this become? 3 by 2 R square, whole thing divided by 1 plus 1.5, 2.5, which is nothing but 5 by 2 times of R. Now 2 R cancels, so it will become 3R divided by 5. So that is the final answer. So this is basically your R equivalent. So R equivalent is nothing but 3R by 5 ohms. 3R by 5 ohms. Yeah, just check it out. Everyone with me? Yeah, awesome, awesome, perfect. So over here, what we have done is these two were in parallel, so R by 2. R by 2 in series with R, so it will be 3R by 2. 3R by 2 is in parallel with R, so R1 R2 by R1 plus R2. So this will be 3 by 2 R square. This will be 5 by 2 R. 2 R cancel, so 3 by 5 times of R will be remaining. Correct? Perfect. Very good thought, me, Archit, Rama, Patels, everyone. I hope it is absolutely clear. Very nice. Great. So let's do some questions coming up on your screen. And here it comes, the first previous year question on your screen. Here it is. It looks like a complex problem, but actually it's simple. The equivalent resistance between A and B in this given diagram is. If you notice carefully, then you will realize that actually it is not that difficult, because over here, see guys, this is point A, current is coming in like this and current is going out from it like that. All these resistors 10, 10, 10, 10, and even these two actually are in series. So if I find their equivalent, 5 plus 5 is nothing but 10 ohm. So all these 10 ohms, one branch and this branch, most of them looking like parallel, but there is a 5 ohm resistance to spoil our mood. Okay, no problem. So first, this 10 ohm and this 10 ohm, if you notice, this 10 ohm and this 10 ohm, they both are in parallel. So the equivalent will be this 10 and this 10 will be 10 divided by 2. Isn't it? It will be 10 divided by 2. Okay, which is nothing but 5 ohms. Awesome. So if that is 5 ohms, I can just get rid of this, and this, of course. And I can just say, listen boss, now I have a single 5 ohm resistance. So I have just made all these people disappear. 5 plus 5 was 10. 10 and 10 were in parallel, so 5. So this entire thing is basically 5 ohms. Now observe carefully. You will again realize that these two 5s are again in series. So 5 plus 5 is again 10 ohm. And this 10 and this 10 are again in parallel. Can you see that, my dear students? This 10 and this 10 are again in parallel. So in parallel, it will just become 10 by 2, which is again just 5 ohms. It's like a repeat process, if you may see. So what happens is you can again get rid of this 5 became 10 along with this 10 over here. Okay, so we now have just a simple 5 ohm resistance. Same process is getting repeated, guys, again and again and again. That's all. So it is same thing if you notice. Yep. So again, these two 5s are in series. So it will be 10 ohm, and this 10 along with this 10 was in parallel. So 10 by 2, which is 5 ohms, which is 5 ohms. Replace that again. Well, you are very close to the answer. See, this time I'm doing it step by step, but actually speaking in the exam, I know that it is a repetitive process. I will directly go to the last step. I won't keep doing this 100 times. This is just for your explanation. So this is 5 ohms again. So obviously these two are in series. So that is 10 ohms. And now these two are obviously in parallel. So it will be 10 by 2, which is basically 5 ohms. So equivalent resistance between A and B is 5 ohms. That is the answer. Is that right? Everybody understood how we did this? So, the immediate next step only would be exactly this. You would just have this particular point A, and there will be a single resistance between them, and that will be 5 ohms. You replace all of them with one resistance of 5 ohms. Simple. Yes, missed. Perfect, Kevin. Yes, 5 ohms. Yes, Zoru. Yes, Rama. Option C. Perfect. So once you see the trick over here, you know it is repeated. So in the exam, don't waste the time which I did now. This is just for your understanding, because this is obviously your first PYQ which you are solving with me. So I took some time to explain it to you. But in the exam, you'll be like, oh, same thing again and again. So till the last thing, it is just going to be 5 ohms and 5 ohms. So 5 series and parallel. So it will be 10 ohms plus, 10 ohms by 2, which is 5 ohms. Great. Perfect, sir. But sir, once I saw this kind of question, sir, R by 3, R by 3, R by 3, what is the equivalent resistance? Then I was like, sir, won't the current flow like this? Oh my God, what will it do now? Sir, current will go like this, and what will it do now? So a lot of people get confused in such questions. These questions are called disguised questions. You understand what is disguise? You wear a mask. You pretend to be somebody. Okay? You wear some mask, like in Mission Impossible, Tom Cruise is wearing some mask of somebody else. And then when you remove the mask, then you realize, oh, it's Tom Cruise. So, same way, this problem is also wearing a mask. You need to uncover who is really behind this. And how to do that? Will you hire a detective? No need. You just hire me. I'm your Captain Shreyas. And I'll tell you how. What you need to do is, it's called the method of voltages or potentials. Whenever you see a wire, all the points on that wire are like shorted or at the same voltage. If there is some 5 volts, all the points on the wire, because there is no resistance of that wire, we assume ideal wires. So all the points have same voltage. So start marking that, and then see if there are any things which have same voltage differences, or they are sequentially arranged. This voltage plus this voltage plus this voltage. If it is sequentially arranged, V1 plus V2 plus V3 is the net voltage. Obviously, they are in series. But if the voltages are the same, then they are in parallel. Let's see how. Say, for example, you start marking, let's say, this particular point as voltage V1. So this point is also V1, same wire. Okay, go like this, same wire. So this is also V1. All these points are V1. Now, if you go over here, this point, let's say V2, let's assume that, and this point will also be V2. This point will also be V2. Same wire continues. This is also V2. Now, observe carefully, guys. Observe carefully. on one side you have voltage V1 and on the other side you have this voltage V2 coming from here. All the resistors R by 3, R by 3 and R by 3 have the same voltage difference V1 minus V2, V1 minus V2, V1 minus V2. So look at it carefully. All the resistors, have same potential difference, which is V1 minus V2. What does this tell you? They are in what? Series or parallel? Obviously, they are in parallel because only in parallel the voltage differences are the same. So actually, this is a disguised way of writing parallel. Actually speaking, they are, like this. It's just like this. They are all in parallel. All of them are in parallel like this. So this is R by 3, this is R by 3, this is also R by 3. A lot of people have said, they are in series because they are one after the other, but no, they are not exactly, because there is some branching happening over here. The moment a branch happens, things change. There should be no branching then if they were in series. So now it becomes obvious, since they are all in parallel, what will be the equivalent? So R equivalent will be, you take any one of the resistors, which is nothing but R by 3 by the number of resistors. So it will be R by 9, which is option number D, of course. Is that clear, everyone? It will be R by 9, yeah, because 3 resistors in parallel. So each resistor by the number of resistors. Perfecto. Yes, missed. Perfect. Praga, you said it before, is it? So please say when the syllabus and maximum. Zoro, we are following the NCERT, yeah, and by around October, November, yeah, we should be done. Yep, correct. Yes, Praga, that is absolutely correct. No, it is not A. Yeah, it is not R. Yeah, it is definitely D. Yeah, we are covering all the topics. Correct. So this is method of voltages which you will use to uncover the mask or the disguise. So whenever you think it's actually simple, but it's drawn in a tricky way, you can either visualize it, which is usually difficult, or just mark the voltages. In a wire, all the points are always at the same voltage. If the voltage differences are same, it's in parallel. If the voltage differences are in sequential order, V1 minus V2, V3 minus V2, V4 minus V3, V5 minus V4, like that, then they are one after the other. So that means it is in series. Okay, let's see. How about this particular question over here? This also, I feel, which was a previous year question, is also a disguised form. I think we just need to figure out, how they are working out exactly. All right. So let's start marking the voltages. Nothing bad in that. So there is only one wire here directly between A and B. Okay, let's just forget that. Okay, we can just say, okay, this particular point is VA and this particular point is VB. Okay, fair enough. Now over here, let's say I take this point as V1. This wire is going like this. This is not connected. There is a jump in it. This is also going to be V1. Okay, fair enough. And if I assume this point to be V2, same wire is going here and this is connected like this, number 1. Okay, next important thing that I can see, these two are connected one after the other. So actually they are in series. So 4 plus 11 is 15 ohms. These two are also in series. So 8 plus 7 is also 15 ohms. Perfect. This 10 and 5 are connected one after the other. That is also 15 ohms. Nothing else over here. So technically speaking, what we can do is that we can replace these resistors with one single resistance. So I can get rid of this. All this was 15. And even this was also 15. Yeah. So I can just say, listen, boss, there is 15 ohms here. Okay. There is 15 ohms here. And this is 15 ohms over here. Fair enough. Now what do we do next? Observe. Now what do we do next? I think we should redraw this circuit. We should just redraw this circuit. Start from A and slowly go towards other points. So let's say you start from the point A. The first resistance that you get is that 6 ohm resistance over here, and immediately you get that point labeled V1. I'm just redrawing it. Now there are two branches. One branch goes here, one branch goes here. Okay, this branch is definitely connected to one 15 ohm resistance. So there is one 15 ohm resistance directly connected between V1 and V2. Okay, let me mark this particular point as, let's say, V2, and V1 is connected again with a 15 ohm resistance to V2. Okay, so V1 is again connected via another 15 ohm resistance directly to V2. Can you see that? Also, that same V1 is connected via 15 ohm resistance to again V2. Okay, so there is another resistance maybe like this, and it is connected to V2. So this is what it is. So from V1, this, and this all are connected to V2 only. This is also V2, this is also V2, and this is also V2, which I have combined it into a single point. But this V2 proceeds ahead, with another 8 ohm resistance, and it is connected to point labeled B. So this is the equivalent diagram. Everybody gets this? Yeah? Everybody gets this? All right. October. Yeah, October will be done. Yes. So in this particular problem, what we first did, we saw there are some simple series resistors. So like this is 15, this is 15, 10 plus 5 is also 15. So first we condensed these three series resistors into 15, 15 and 15. Now we mark the voltages. If this is V1, this is also V1. If this is V2, that is also V2. So we started from A, we proceeded towards V1. Proceeded towards V1, we encountered 6 ohms. V1 is connected via 15 ohms to V2. Also, V1 is connected via 15 ohms to V2 again. And V1 is again connected via another 15 ohms to V2. That is what we saw. And this V2 overall is connected via 8 ohms to B. So it's a simple procedural, go step by step, start from a point, finally end up at another point. Yeah. Now is it clear, everyone? VFX, everyone? Absolutely clear? Yeah, missed, perfecto. Yeah, just have to do it. Yes, Darshan, absolutely clear. Now, what are these three resistors in, guys? What are these three resistors in? Can you see that clearly? What are these three resistors in? Obviously, these three resistors are definitely in parallel. So equivalent will be 15 by 3, which is nothing but 5 ohms. So in the next step, I can just say, listen bro, let me just get rid of these things. And this is no longer 15. I can just say, this is 15 by 3, which is nothing but 5 ohms. Now these three are obviously in series. All of them are now in series resistances. So combination. So this will be 6 plus 5 plus 8. Is that right? Everybody with me? Understood? Clear? Okay. So 6 plus 5 is 11. 11 plus 8 is basically 19 ohms. So the final answer is C option for your Captain Shreyas, which is 19 ohms. Okay, that's how you do it. So beautiful question. Okay, it didn't look like an easy question. Many people who have studied Kirchhoff's laws, they start thinking, should I apply circuit laws, assuming currents? I'm like, wait, man, chill, bro. First, yeah, see whether some things are disguised. Maybe some things are simple. Already they are in series. So first get rid of them. So first I got rid of them. Then I marked the voltages, and then I'm like, oh, wait a minute. This 15, this 15 and this 15. V1, V2, V1, V2, V1, V2. Same voltage difference. So that means they are in parallel. So I immediately saw three resistors in parallel and their combination was in series. So immediately I got the answer. Okay, perfect. Yes, sir. Understood, sir. Sir, let's do another tricky question, sir. Oh, 30th Jan 2023. Sir, what a nice design, sir. But how do I solve this? Looking scary. Trust me, it is not until you start seeing few things, maybe series and parallel. First of all, I have already started seeing couple of things which are directly doable. Directly doable. Like for example, this one. Oops. Like for example, this one. This 1.5 and this 0.5. They are in series. They are in series. So that will be 1.5 plus 0.5 plus 0.5, which is 2 ohms. Same thing over here. Can you see? 1 plus 1 will be 2 ohms, right? We are already able to see that. Next important thing, okay, next important thing, which I can see is that this point, this point, this point, and this point all have the same voltages. V1, 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 V1. Clear? Next, all these points, this point, this point, this point, and this point. If this is V2, this is also V2, this is also V2, this is also V2. Perfect. Lastly, this point, something else, voltage V3, because there are resistors in between. Now, keeping all this in mind, let's do the simplified diagram. Let's draw the simplified diagram. First, we got rid of the top resistors over here. Okay, we got rid of the top resistors over here. Okay, this one and this one, of course. So the moment I get rid of these resistors, so I can just say, that is nothing but another resistance like this of 2 ohms, and this also another resistance of 2 ohms. Number one. Another thing, apart from this 2 ohm and this 2 ohm, look at 8 and 2. V1, V3, V1, V3, V1, V3. This 4 and 6, V3, V2, V3, V2. So can you notice that 8 ohm is actually parallel to 2 ohm with a potential difference which is V1 minus V3, V1 minus V3. Same thing, 4 ohm is parallel to 6 ohm and potential difference, can you see potential difference is V3 minus V2, V3 minus V2. Can you see that? V3, V2, V3, V2. So I can look at them in parallel. And if I look at them in parallel, guys, what is this equivalent combination going to be? R1, R2 by R1 plus R2. 8 2s are 16 divided by, this is 10. So this is 1.6 ohms. So 8 and 2 together between V1 and V3 is 1.6 ohms. Same thing, because they are in parallel, R1, R2 by R1 plus R2. So 4 into 6 by 4 plus 6, that is 24 by 10, which is 2.4 ohms. So I can now say I no longer need this. No longer need this over here. Yeah. Instead, I can just say, listen, bro, this is V1, this is V1. This is V2, this is also V2. And in between, we had some V3 over here. Is that right? V1, V3, V2. 8 and 2 together was 1.6. So I can just put over here a single resistance of 1.6 ohms, and between V3 and V2, it was 2.4 ohms. So this is nothing but 2.4 ohms. Is that right, everyone? With me on this? At a particular point, I'm just assuming, Darshan, this is method of voltages where I assume the voltage is V1. No harm in assuming. And wherever the wires are connected, same voltage. If there is something in between, then I am assuming different voltage. So observe carefully again over here. If you notice, this is the same wire going till here. Moment I go across this, this will be something else, this will be something else, this will be something else. So I can assume all these points to be at the same voltage, all the points on the same wire to be at the same voltage. The moment I go here, something else voltage is there. Is that now clear, Darshan, Zoro? Yeah, perfect, awesome. So then what I did, 1.5 and 0.5 is 2, 1 and 1 is also 2. These two ends are 2 ohms and 2 ohms. See this, 2 ohms and 2 ohms. Can you see 8 and 2 are between the same voltage differences, V1 and V3? So they are in parallel. And for parallel, what's the formula? R1 R2 by R1 plus R2. Same thing for 4 and 6, V3 and V2, V3 V2, V3 V2. Same voltages means what? They are actually, you can just combine these two ends together. So 4 and 6 will be in parallel. 8 and 2 was in parallel. So 4 and 6 in parallel is 2.4 ohms. So I replace these two and these two with 1.6 and 2.4 ohms. Now does it look solvable? Now does it look solvable? Guys, I'm pretty sure it looks solvable. The next step itself should tell you, guys, this 1.6 and 2.4, if you add them, they are in series, right? This two are in series, right? So in series, what will be their effective combination? 1.6 plus 2.4. Yeah, it will be 4 ohms. Is that right? That will be nothing but 4 ohms. Awesome. So I don't need these two resistors anymore. I don't need these two resistors anymore. And I can just say I have just a single 4 ohm resistor. Now all of them are in parallel. All of them are in parallel. Can you see? 2, 12, 4, 6, 2. Same voltage, V1, V2, V1, V2. All of them are in parallel. Can you see that? Now all are in parallel. So 1 by Rp will be 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus 1 by R5, whatever. Okay, that's it. That is all you need to do. Is that clear, everyone? Okay, you learned that in class 10, great, but some people forgot, I think, nevertheless. Now do the maths. Yes, the LCM is already there. It is basically 12. Come on, it's 12, is it? Yeah, it's 12. So put 12 over here. This will be 6 plus 1 plus 3 plus 2 plus 6. That's it. How much by 12 is 1 by Rp? And then how much will be Rp? Just think about it. Yeah. 6 plus 1, 7, 7 plus 3, 10, 10 plus 2, 12, 12 plus 6, 18. So this will be 18 by 12 divided by 6 is 2, divided by 6 is 3. So flip it, it will be 2 by 3 of a ohm. So 2 by 3 of a ohm is option number A. Yeah, that's it. That is the correct answer. Nice. Understood how to get this? Okay. So all these kind of questions are at the end of the day series parallel combination. No need of any symmetry, no need of Wheatstone, no need of KVL, no need of circuit laws, no need of any other complex formulas, star delta, this, that, all bakwas, full to bakwas. Okay, no need. You just can solve it via simple series parallel combination. The more you solve, the more you start seeing things, because now you might be a little bit stressed, or maybe under that pressure, oh, I have to solve it before the other person in a live class. But with time you will get it. You will immediately start saying, oh, series. Okay, you won't even do so many steps. Orally only many people solve it. They directly see, oh, 8 and 2 are in series, parallel, 4 and 6 are in parallel. Okay, they 2 are in series. Okay, this is that. Directly they write this diagram without even drawing intermediate. And then they say, oh, all of them are in parallel. So use this reciprocal addition formula. Cool, Rama. Perfect. Awesome. Awesome. Did you love this question? Yes or no? Are you loving the examples that we are solving? Boosting your brain capacity power, firing up all the neurons. Okay. So now let's do the current distribution related questions, where you might be asked to figure out how much current is flowing through this part, how much current is flowing through that part, etc. Okay, so keep this in mind. So most of the times you are going to solve these kind of questions as well, where you are asked a voltage across anything or finding the current across anything. All right. So just to give a simple example, let's say a circuit is there like this. and let's say this is V, and this is usually the symbol for grounding. Maybe this is, I don't know, 2R, or let's say 3R, this is 6R, this is R. Can you find the current in each resistor and each branch? Okay, maybe that is the question. So what do you do in such case? Always start by reducing the circuit into a simpler circuit. So like over here, if this is V volts, this is this resistor R, these two are in parallel, as you can easily see. So because they are in parallel, it will be R1 R2 divided by R1 plus R2. So 3 6 are 18, 3 plus 6 is 9, 18 by 9, which is basically 2R. So instead of these two resistors, I can just put one single resistor of 2R resistance. Okay. Now, once I get this, I can immediately see that, wait a minute, these two actually are in series. These two are actually in series. So I just put V volts over here and one single resistor and connect it to ground. Ground means 0 volts. So 2 and 1 will become 3. So this will be nothing but 3R. Perfect. So this is the equivalent resistance. Now once you get this, keep in mind you have to do exactly reverse to find the current distribution or voltages. Yeah, go exactly reverse. What do I mean by that? Observe. See, first of all, over here, if you ask me how much current is flowing, I can say current is voltage by resistance. Voltage is V because this is 0 volts by resistance. So V by 3R. V by 3R is the current in this equivalent resistance. Go reverse now. You have to start going reverse. Whatever you did now, go reverse, meaning like this. Start unreducing it. You had reduced the circuit, now go reverse. That's it. You will start getting the answers. Okay, I don't need this anymore. Yeah, just start going reverse. See, if this was the current here, in series, the current is always the same. So both of them should have the same current. So current will be obviously V divided by 3R. Now go furthermore, you will start saying, okay, whatever current is there here will be the same. Oops, whatever current is there over here will be the same. So this current will still be V by 3R, but this current will get distributed here and here. Can you see that? This current will get distributed here and here. This will be I1, let's say this will be I2. This current is definitely getting into two branches. Now, how to find I1 and I2? How to find I1 and I2? Come on, guys, think about it. Yeah. Well, the voltages are same across both of them. The voltages are same across both of them. So, what is that voltage across this? Let's say I call it V dash. Let's say we call it V dash. This V dash is current multiplied by resistance. Current multiplied by the resistance. Current was V by 3R. Resistance is 2R. RR cancels. You will get 2 times V by 3 is V dash. The voltage across this is 2V by 3. The same voltage will also be there over here. The same voltage V dash will also be there here. That's it. That's the logic for this. So if I write V dash, I can say it is this current, which is I1, multiplied by this resistance, which is 3R. Okay. So therefore, I can say current 1 will be V dash. V dash is 2V by 3. V dash is 2V by 3 divided by 3R. So how much will it come out to be? I1 is equal to 3 3s are 9. So 2 by 9 V by R. That is this current. How do I find this current? Again use V dash, the voltage across this is that current multiplied by that resistance. Okay. So therefore, the current will be V dash by 6R. How much is V dash? It is 2V by 3. Perfect. So here we can say 2 by 6 multiplied by 3, V by R. So 2 and 6 cancels, it becomes 3. 3 threes are 9. So 1 by 9 V by R. So that is current number 2. So we have found out everything. We have found out everything. Clear now, everyone? Okay, everyone? Is voltage equal to potential? Voltage and potentials are the same, but when we traditionally use the word voltage across a resistor, voltage across something means voltage difference or potential difference. Voltage, potential means the same. I want to find the voltage across this. I want to find the potential across this. Means the same. Potential difference, voltage difference, it means the same. But potential is different from potential difference. Potential means actual voltage, volts. Okay, at a point, potential at a point. Whereas potential difference means the difference of the two voltages, V1 minus V2. So in Ohm's law, that V is equal to IR. V is never the potential, it is always the potential difference across the two ends of the resistor. Okay, clear? Perfect, Rama. Everyone, Uttarani, Ame, Kevin, Shan. Yeah, I'll take wave optic Shan later on, but not now. Yeah, there's quite some time for it. Great. So let's see if you can figure out this particular question, which was asked in JEE Mains 2025 this year. R1 is given 10, R2 is given 8, R3 is given 4, R4 is given 8. Battery is ideal, EMF is 12 volts, equivalent resistance of the circuit and the current supplied by the battery. Basically, as you can see over here in this particular diagram, if I tell this point is V1, this is also V1, this is also V1, this is also V1, this is also V1, and notice how this point, this point, this point, this point, V2, 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 all of them are in parallel. Can you see that? Can you see that? All these three resistors technically are in parallel. So, to find that equivalent combination, 1 by Rp will be 1 by R1. R1 over here is R2. R2 is 8 plus 1 by R4. R4 over here is also 8 and R3. R3 is 4. So, this is 1 by 4. 1 by 8 plus 1 by 8 is 1 by 4 plus 1 by 4, which is 1 by 2. So, therefore, equivalent resistance is 2 ohms of these three. So, what we can do is we can get rid of all these three resistors, in total, and then we can say, listen bro, this was R1, right? R1 was how much? 10 ohms. Oops. R1 was 10. R1 was 10 ohms, and this one, we just figured it out, all three together is nothing but 2 ohms. So this is nothing but 2 ohms. Now they both are in series. So clearly the equivalent resistor will be 10 plus 2, which is 12 ohms. So if you are asked what is the current in the circuit, it will be the total voltage divided by the total resistance, which is just going to be 1 ampere. So 1 ampere and 12 ohms, which is option D. Clear how to solve this? Yeah, perfect. Perfect. This was asked this year. Can you believe that? Yeah. Not that difficult, but when you figured it. Very good, Rama, Kevin. Awesome. Awesome. Now, let's solve this particular question, which is a PYQ of 2020. This is very good question. I think the diagram is not so clear, so I'll just draw it. Meanwhile, read the question. The question is to find, I think, the current or something, wire joining B and D. Very nice question. Many students got confused in this. If you can solve it in the first go, hats off to you. Okay? Hats off to you. 1 ohm, 4 ohm, 2 ohm, 3 ohm. Okay. Now, first things first, I can see few things are in parallel and their combination maybe is in series. Like how? Observe carefully. See, this point, and this point. If this is A, this is also A, this is also A volts. Similarly, If this point has voltage of C, this is also C, this is also C, this is also C. Okay. Lastly, if I take this point as some potential, this everything is at that same potential. So this is also B, this is also technically B only. So if I try to reduce that circuit, it looks something like this. It's like saying 1 and 4 are in parallel. Can you see that? Now 1 and 4 are in parallel. So equivalent will be 1 into 4 by 1 plus 4, which is 4 by 5 ohms. Same thing about 2 and 3. They are in parallel. So 2 into 3 by 2 plus 3, which is 6 by 5 ohms. Everyone? So the equivalent would look something like this. You will have one resistor here, another resistor here, this particular battery like this. This is 20 volts. This will be 4 by 5 ohms. This will be 6 by 5 ohms. This is your point B. This is your point A. And this is your point C. This is what you are going to observe. Correct me if I'm wrong. Yes, everyone. Can you see this and this same voltage differences? Same voltage means parallel. Same voltage difference means parallel circuit. Oh, perfect. So now we can easily reduce this into a single resistor, of course, a single resistor. And how much will that be? They both are in series. So obviously 4 by 5 plus 6 by 5 is 10 by 5, which is 2 ohms. But that is not the answer. Obviously, we have to find the current. Current will be voltage by resistance. Voltage is 20 divided by resistance, which is 10 amperes. Now, 10 amperes is not even there in the option because that is not even the question which is asked. See, this current is the net current in the circuit, but that is not the actual current which is flowing between these 2 points. Oh my God. Yes, correct, sir. You are right. So what do I do now? What do I do now, sir? What do I do now, sir? I'll tell you one thing. See, this 10 amperes, when it comes, it will flow through this guy also and this guy also. So when it flows through 4 by 5 ohms, how much voltage will it create? VAB. How much will that be? And how much will VBC be equal to? Let's just find that out for our sake. Chumma, okay? Maybe that will help me figuring out individual currents, because whatever voltage is there here will be across 1 and 4. Whatever voltage is there here will be across 2 and 3 because they are in parallel. Okay, VAB will be I into R. Current, okay, the same current will flow here, and will flow like this. Of course, the same current of 10 ampere. So VAB will be I into R. I is 10. Resistance is 4 by 5. 4 by 5. 10 by 5 is 2. 2 4 is 8. 8 volts. Similarly, VBC current is 10. Resistance is 6 by 5. 10 by 5 is 2. 2 6 are 12. So 12 volts. Okay. So I got voltage across this and voltage across this. Now I have an idea. You know what that idea is? Sir, your idea will be crazy, sir. Yes, it is going to be crazy. Observe. VAB, this voltage is 8 volts, right? So how about saying across these 2 points, the voltage is how much? We said 8 volts. Okay. It is 8 volts across these 2 points. And across these 2 points, it is 12 volts. Okay. It is 12 volts. Perfect. Okay. This 8 is across 1 and 4. This 12 is across 2 and 3. All of them are in parallel. Observe now carefully. Observe now carefully. If I say this current is I1, this current is I4, this current is I2, and this current is I3. Since by Ohm's law, we know Current is potential difference by resistance. V is IR, I is V by R. Ohm's law. Think logically, what will I1 be? I1, yes, I1 is over here. Okay, if it is not seen clearly, this is I1. Voltage difference by resistance. Voltage difference is 8, by resistance is 1, so it will be 8 amperes. What will I2 be? Sorry, not I2, I4. What will I4 be? Voltage difference by resistance. Voltage difference is 8 by 4, which is 2 amperes. What will I2 be? I2 be, voltage is 12, resistance is 2, so that will be 6 amperes. And this I3 will be voltage, which is 12 by 3, which is 4 amperes. What did you get with this? I'll tell you, man. I'll tell you. See, let me just show those currents. These are all lengthy questions. That's how JEE questions are. You cannot expect, sir, which formula you should use, sir. See, some students are there and some coaching institutes are to be blamed for this. Coaching institutes which run from 8 o'clock to 6 o'clock. Many of these coaching institutes, one of my, 2-3 of my relatives I have seen. They were studying in these coaching and I told them, please don't study here. They'll just make you mug up things, but actual question paper could be difficult or not like that. And it's not because I was in Vedantu or anything, but even if I was somewhere else, I would have told, please don't be like that. Don't by heart formulas. You have to always learn to think. So, end of the day, couldn't clear. That was the problem. Anyways, so let me mark. I1 is 8, I4 is 2. 8 and 2. This is 8 amperes. This is 2 amperes. This is 6 and this is 4. This is 6 and this is 4. Now I think you can get it. Now I think you can get it. Just, yeah, think about it. Just think about it. Now I think you will be able to get it. Guys, see what is happening at point B. If you realize, that's it. What is happening at point labeled B? That is more than enough. 8 amperes is entering in and here 6 amperes is going out. Where is the remaining 2 amperes going? Obviously, it will be going like this. Oh, sir, 2 amperes is going like this. Won't it create a problem? Don't worry, man. See, even if it goes to point D, here from this side, you are getting 2 amperes. Can you see that? 2 amperes you are getting from here. This 2 and this 2 will combine and become 4, which is exactly the case. Oh, so between point B and D, how much current is going? 2 amperes. So that is the answer. C for Captain Shreyas. Clear how to solve this? How many of you loved this question? It was not so straightforward. Yeah, see, it was at the end of the day series and parallel only. Oh, these two are in parallel. These two are in parallel. Okay, sir. But these two are in series. Okay, sir. Combined it, found equivalent resistance, found the total current. That current will go through both these resistors. But the question was to find between these 2 points how much current. So I thought, if I knew this current, then I think I can find this current. But how do I find this current? I need the voltages across them. So I found the voltages between these two and these two. So those voltages were IR. Separately I found out. Current was already found. So once I found out those voltages, I found out I1 and I2. Actually, I didn't need I4 and I3. But chumma, I found it out for clarity's sake. Just with I1 and I2, I could have solved the question. Just imagine this. Just with I1 and I2, I could have solved the question. Yeah, I could have just said, okay, 8 amperes is coming in, 6 amperes is going out. So where will the remaining 2 amperes go? It will obviously go between B and D. That's it. Done. Dusted. How many of you loved the question? Got it, Rama? Punit, good question. Yeah. Kevin, what is the trick? Oh, thank you so much, Soldy. So, sold my soul. Oh my God, what a name. Yeah. Great. Simple and clear. There is no trick. There is no trick. The trick is to solve it step by step, reduce the circuit to the simplest form, and then go back. What did I do? I reduced the circuit, tuck, 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 and again went back. See, again I'm going back to the original circuit. From here, I found these things. And from these things, I found these currents. So most of the times, it's going front and again resolving it back. Most of the times. Thank you, Sai, so much. And I hope you guys are smashing that like button down there. Thank you, Sana, so much. Yeah. Super, Zoro. Very good. Good evening, Sai. Yeah. All right. Great. Great. Next. Next. Wow. Do we have another amazing question over here? Yes, I think we have. The total current supplied to the circuit by the battery is. What a question, guys. Yeah. What a question. I think it is some series parallel only. It's just that it is not shown in that beautiful form. Okay. Let me take this point. Let me assume this as V1 voltage. Same V1 is also there here, only till this point. Okay. Then let me take this point as V2 voltage. Same thing is there till here and here also and here also. And there is some resistor in between. So this will be something else. Okay. So technically, if I show that battery of 9 volts, that positive terminal is going to V1. Okay. That positive terminal is first of all going to V1. That V1 is going via 1.5 to V3. That V1 is going to V2 also. Okay, fair enough. And that V2 is again going to V3. And that V3 is going to V2. Oh my god, so many things are happening. Fair enough. First of all, V1 is going via 1.5 ohms to V3. Let me show maybe 1.5 ohms over here. And it is going to maybe over here. And let's say I call that as V3. Let's say I call it V3. Another resistance of 3 ohms. No, it is not going directly. Okay, this is directly V3. V1 is going to V2 and V2 is going to V3. Okay, between V1 and V2 there is a 3 ohm resistance. Okay, so what I can do, I can just take this like this. Between V1 and V2 there is a 3 ohm resistance, and let's say this is V2. That same V2 is connected to the negative terminal. Okay, so that same V2 I can say is connected to the negative terminal, and also V2 is connected to V3 by 6 ohms. V2 is connected to V3 by 6 ohms. Okay, that is what it is, 6 ohms. Check this out. This is the equivalent circuit. This is the equivalent circuit. I just drawn it naturally. Start from a point, keep moving ahead to the next point. Started with the positive terminal. Positive went to V1. Positive went to V1. Connect 1.5 to V3. Connect 1.5 to V3. Okay. V1 connecting to V2 via 3 ohm. V1 connecting to V2 via 3 ohm, but V2 is connected to the negative terminal. V2 is indirectly connected to the negative terminal. Also between V2 and V3 there is 6 ohms. So between V2 and V3 we did 6 ohms. Now it is easy. Yeah, now it is easy. How? Well. These two are in series. These two are in series. So you might as well get rid of these two. These two are in series, of course. So you can just write one single resistor over here. So 1.5 plus 6, that's 7.5 ohms. That is 7.5 ohms. These two are in parallel. 7.5 ohms is nothing but 15 by 2 ohms. Okay. Now these two are in parallel. So when you combine these two together, you will get a single resistance. You will get a single resistance over here. This is V1 and this is V2. How much will that resistance be? Just think about it. Since they are in parallel, Rp will be R1 into R2 divided by R1 plus R2. Okay. So this is 15 3s are 45 by 2, whole thing divided by 3 2s are 6, right? 3 2s are 6, 6 plus 15, that is 21 by 2. 2 cancels, 45 by 21. So 45 by 21 divided by 3 is 7, divided by 3 is 15. So 15 by 7. So this equivalent resistance will be nothing but 15 by 7 ohms. 15 by 7 ohms. Everyone understood till this point? Yeah, very good. Now the total current supplied to the circuit. Well, now it is easy. So this particular current will be the total voltage, which is 9 volts, by the total resistance, which is 15 by 7. So 9 multiplied by 7 by 15. 9 goes with 3 3 times, 15 goes with 3 5 times. So 21 by 5 amperes. 21 by 5 is close enough to 4 amperes. So close enough to D option. Okay. So yes, this particular D option you can say is the closest one. It is not exact, but it is approximately, I can say it is 4 amperes, approximately. Yeah. Where is 2 ohms? Did I miss something? V3 and V2, did we miss something? V3 and... Oh, sorry guys, I'm so sorry. I'll have to delete this. I'm so sorry. I think I missed one resistor in between V3 and V2. Between V3 and V2, I missed that 2 ohms. So sorry. So there was one more resistor over here between V3 and V2. That was 2 ohms. So sorry. Yeah, my bad. This was also there. So if this is there, then what do we do? Well, see, this 6 and 2 are basically in parallel. 6 and 2 are in parallel. So if you think about it, if you combine these two, which are in parallel, it will be 6 into 2 divided by 6 plus 2. 12 by 8 divided by 4 is 3, divided by 4 is 2. So 3 by 2, which is basically 1.5 ohms. Now this 1.5 ohms and this 1.5 ohms, this is 1.5. This is 1.5 ohms and this is also 1.5 ohms. They both are in series. So if they both are in series, so I can replace that with a single resistor of 3 ohm. Is that okay? I can replace these two 1.5 ohms with a single resistance of 3 ohms. Now these two 3 ohms are in parallel. So I can replace that with one single resistor. I can replace that with one single resistor over here. Yeah, I can replace that with one single resistor over here. This is your V2. Yeah. So 3 and 3 in parallel, what will happen? It will become 1.5 or 3 by 2. It will just become 3 by 2 ohms. Is that fine now? This will be 3 by 2 ohms. Yes. Perfect. Perfect. Everyone? Great. Great. Yes. Okay. Yeah. Now, what do we do now? Here, this particular current will be the total voltage, which is 9, by the total resistance, which is 3 by 2. Well, this will be 9 into 2 divided by 3. 3 goes with 9 3 times. So 3 2s are 6. So 6 amperes, which is option C, will be the correct one. 6 amperes will be the correct answer. Is that absolutely clear, everyone? Yep. Awesome. Hey. Please guys, don't spam out there. Yeah. Yeah, don't spam. Anybody causing some issues, yeah, will be blocked then. Yeah. Like Namrata. Okay, fine, Madhuri, definitely. Yeah. Yes. Great. Perfect. So these are some amazing questions which we have been solving on current distribution. Let's do some more special questions. On equivalent resistance. Like for example, this one. This is a wire. Okay, again, these are equivalent resistance. There is a wire of length 25 meters and cross section 5. Resistivity 2 into 10 to the power negative 6 is bent into a circle the resistance between the diametrically opposite points is. Okay. First, let me consider that wire whose length is 25 meters. Wire length is 25 meters. This is obviously a big resistance. How much will be that resistance? If resistivity is given, length is given, area is given, use the formula rho L by A. Resistivity is 2 into 10 to the power negative 6. What is the length? It is 25 meters by area. 5 millimeter square. Millimeter square means 10 to the power minus 6. 10 to the power negative 6 will cancel. 25 and 5 will cancel. You will have just the number 5 on the top. This 2 was there. 2 5s are 10. So the total resistance of that wire is 10 ohms, but don't mark 10. It is not even there in the options. This is just the length of the wire. You take that wire. You just take that wire. And what you are doing now? You are converting it into a circle. Okay, sir, I will convert it into a circle. And now you want to measure the resistance between the diametrical opposite points. That means this and this. These are like two resistors in parallel. If you notice carefully, this is one resistor here and there is another resistor over here. A lot of people are now going to jump and say, sir, just divide by 2. So 10 by 2 means 5 ohms. But that is not correct, guys. Be careful. See, when you bend this straight wire into a circle, each part will be 5 ohm each because total length had 10 ohms. Half the length will have 5 ohms and 5 ohms each. Now, they both are in parallel. So, when you convert it into a single resistor, it will be 5 by 2, which means 2.5 ohms, which is option B. Got it? Very good, Rama. Awesome. Yeah. Amai, you're going to get blocked, man. Yeah. Don't spam and don't flirt over here, especially. Yeah. 2.5 is the correct answer. Loved it? Okay. How about this particular question? Will you be able to do it now? A wire of some resistance R is bent into a square. The effective resistance between E and C is how much? Effective resistance between E and C is how much? Yeah. Let's see. Okay. Now again, the total resistance of that wire is R. R resistance is for the entire perimeter of that particular square. So each side of that square will be how much? Each side will be R by 4 ohms. R by 4 ohms. Half of the side will be R by 8 ohms. That is also needed because E is somewhere in the middle of D and C. E is the midpoint. Okay, so that's why half the side is R by 8 ohms. This I kept in mind. Then I realized that, okay, fair enough. That means this much resistance is how much? R by 8. This much is R by 8. And the remaining things over here, this is R by 8. This thing over here is R by 4. Correct? R by 4 is each side. This is also R by 4. And lastly, this is also R by 4. And since we have to find the equivalent resistance between E and C, can you notice this R by 8, R by 4, R by 4 and R by 4? One after the other, they are actually in series. So, technically, if you combine them, if you combine all these resistors into one single resistor, you will notice that from that particular point of E on this side versus this side, and this point is C, this point is C. So you have a single resistance between E and C, which is R by 8, and this thing over here, how much is this? Add all of them together. So it will be R by 8 plus R by 4 plus R by 4 plus R by 4. So it will be R by 8 plus 1, 1, 1. So 3R by 4, which is R plus 6R by 8, taking the LCM. So that is 7R divided by 8. So this resistance is 7R divided by 8. Is this clear? Till this point, how many of you got it? How many of you got it? Yeah? How many of you got it? Everyone. Everyone got it till this point? Excellent. Yeah? Clear? Okay. Sai, please don't waste time. Okay, great. There. So this is separate. These all are in series. I added them. Now these two are in parallel. So equivalent resistance in parallel because they are in parallel. R1, R2, which is 7R by 8 divided by R1 plus R2, 7R by 8 over here. Okay. Anyways, this will become 7R square divided by 8 multiplied by 8, whole thing divided by 1 plus 7 is 8. So it will be 8R by 8 over here. A lot of things getting cancelled, like this R square and this R getting cancelled, this 8 and this 8 also getting cancelled. And what am I left with is 7R is there on the top, and this 8 and this 8 will obviously multiply. So 7R divided by 64. So 7R divided by 64 is nothing but your option B over here. Is your option B over here. How many of you got it? Yeah? Everyone? Yes, just check it out. These two were definitely in parallel. That's it. So this was just, you can say it is R also. And this is R1, R2, R1, R2 divided by R1 plus R2. Not 1 by 16. I think some of you made a mistake, Kevin. Yeah, correct. It is 7R by 8. Yeah. 7R by 60. Great. Now, based on this only, I have another question which I want you to solve as homework. Okay, please do it as homework. It is very, very similar. This is your homework question. Okay, where are you going to post the answers? Answer in the comment section. Everyone are going to comment it in the comment section, the answer. I want to see how many of you are able to solve it. This is very beautiful question, very similar to the circle question, but there is some angle given over here. Easily you can do it. Okay, you will be able to do it, yes or no? Perfect. Great. Cool. So now let's go also to this particular ladder question. Let's also go to this particular ladder question where you have multiple resistors one after the other in an infinite form. Usually these kind of questions can be solved just by taking something like, had I forgotten the first two resistors, so you identify the pattern first, like these two getting repeated one after the other. If you forget the first part which is getting repeated, notice this point and notice this point. If I call this A prime and this is B prime, whatever is the resistance between A and B, let's say I assume it to be X. That is also going to be the same resistance between A prime and B prime. Why not? If out of infinity, I have infinite things, out of that, if I take one of it, it will not affect it. Because infinity minus 1 is also infinity. Infinity plus 10 is also infinity. Infinity minus 100 is also infinity. Infinity minus 1 crore is also infinity, because infinite is literally an unexpectedly very, very large, unthinkable number, limitless number. So when you add or subtract from infinity, it does not make a difference to infinity. So out of this infinite ladder, if I take out this is also the same thing as the original figure. So it is the same thing. That brings me to the point that, okay, whatever is there ahead of it has an equivalent of X, which we want to find. So why not forget all the things ahead Okay, this is A, this is B, this is A, this is B. Let me forget all the things which are there in the front completely. And just call it as a simple resistance X. Let me just call it as X. I can do that. So instead of these 2 points having equivalent resistance of X, so whatever is there in front, if the equivalent is X, replace all of them with a single resistance of X. That's it. Now, all you have to do is just series parallel combination. R and X are in parallel. So, RP will be R1, R2 divided by R1 plus R2. So now what will happen is, this is your point A, this is your point B. Okay, you have this particular resistor which is R, all right, and their combination was RP. So that's it. This was Rx by R plus X. And these two in series. So what is their equivalent combination going to be? So RAB, because they are in series, it will be R plus Rx divided by R plus X, because they are in series. But wait a minute, RAB, we had just assumed it to be X. So why not write this as X is equal to, okay, because this was actually assumed to be X in the first place. And here we can just take LCMs, like R into R plus X over here plus Rx, the whole thing divided by R plus X. Now multiply over here. So X multiplied by R plus X is equal to R square plus Rx plus Rx. Again multiply, opening up the brackets, XR plus X square is equal to R square plus Rx plus Rx. Well, couple of things might get cancelled, like this XR and this Rx is getting cancelled, of course. So here x square is there, so looks like a quadratic equation to me. X square, I keep it as it is, bring that Rx on this side, so minus Rx, and bring this R square also on the other side is equal to 0. It's obviously a quadratic equation. Can you see that? So usually these infinite ladder questions are going to be a quadratic equations to solve. So now, not a great route, so just have to solve it by a regular formula, minus b plus minus root of discriminant by 4a, 2a. So here minus b, which is minus of minus r, which is plus r, plus minus whole thing divided by, and root of b square, which means r square, minus 4 into a, which is 1, into c, which is minus r square. So minus becomes plus r square, divided by 2a, which is 2 multiplied by 1. Okay, so this will become r plus minus. Okay, so therefore x is equal to r square can be taken outside the root. It will become just r, and it will be 1 plus 4, of course, divided by 2. Great. So this will become r is common again. 1 plus or minus 1 plus 4 is 5. So root of 5, whole thing divided by 2. Now, of course, the equivalent resistance has to be positive. So I will take the positive root. So 1 plus root 5, the whole thing divided by 2, because this will be a positive value which is valid. But the moment somebody chooses r into 1 minus root 5 by root 2, this is going to be a negative value which cannot be true. So the final answer is this, 1 plus root 5 r divided by 2. Got it? How long will the classes go until January session or April? Vivyas, it will not go until January nor April, it will go until May. It's not a JEE mains batch. Always some trick or something will be there. Great. Fine, sir. So, this same question is also over here. 2, 3, 2, 3, like this. Same thing you can repeat and you can solve the question again and again. You will see that whatever is there in the front, whatever is there over here, again you can assume, my god, 1 second, guys. You can again assume this as X. So whatever is there between A and B is also X. So it is the same resistance between these 2 points. So you again replace them with a single resistance. Okay. And it looks something like this. Yeah, that's it. So this is basically your X, say R is equal to X or X is equal to R. You can assume whatever you want. Okay. So in this particular problem, they have assumed it as R, which is also fine. I assume this as R. So the equivalent resistance is R. Okay. And then you solve it for that R. So again, these two are in parallel and their combination is in series. Solve it. Again, you will get the answer. I've kept a sample problem for all of you just in case you need it. Everyone clear till this point? Okay. Is it absolutely clear how to solve these infinite ladder questions? See what pattern is getting repeated, remove that pattern. The remaining pattern will also have the same equivalent resistance. Assume it as some variable. Replace those things with that. It's a simple series parallel. Solve it. Usually you will get a quadratic equation. See, not just for this problem, even for the next problem also, you have got a quadratic equation only. So solving that quadratic, you will get your final answer. All right. Now let's also talk about batteries in series and parallel. That's also another important type of question. Just 1 second though. 1 second. Okay, cool. Now let's talk about batteries and cells. Observe. Observe. A battery or a cell is basically a device which converts chemical energy stored in it in those electrolytes and it converts it into electrical energy. So a cell basically converts the chemical energy stored in it, into electrical form of energy. We usually call the voltage which a battery supplies as the EMF, electromotive force. Now that name force might be very misleading because it's not exactly a force and force is measured in Newton, but EMF is measured actually in volts. So don't get confused. So when I say EMF of a battery, it is the electromotive force. It is also the work done around to move and or to work done per unit charge from that positive to the negative terminal or from one terminal to the other terminal, from one to the other terminal of that particular cell. And that is the also reason why the unit of EMF is work done, which is joule per unit charge, which is coulomb, joule per coulomb, which we also call it as the volt. So force might be misleading. It's not newtons, it is volts. The symbol of a cell, we all know one big line and one small line. The big line is the higher voltage. The smaller line is the lower voltage, positive and negative terminal. But as the charges move within the battery, not outside, within the battery, they might encounter some resistance within that electrolytes or whatever that liquid or solid is there. So that resistance which is encountered internally is called as the internal resistance. So this is the internal resistance. It doesn't matter whether you show it to the left or right. You can treat it like a resistor placed outside the cell. That's perfectly fine. So it's the resistor which is there inside the battery, which is not actual resistor, but which behaves like a resistor. Because when the charges will move from the negative to the positive terminal within the electrolyte. They encounter some resistance within that liquid, fluid, solid, whatever is there. If R is 0, then it is said to be an ideal cell. Yes, it is called to be an ideal cell, which is not real. You cannot have a battery with zero internal resistance. That's why it's called ideal. Like we say, ideal student. An ideal student is a student who starts his preparation, just after 10th board examination, and every day studying for 8 hours without missing one day of lecture. Every time he has solved all the books, he or she has also completed all assignments. Every test he or she has scored 300 out of 300. Not even one silly mistake that student has done, and that student got all India rank 1. See, people get all India rank 1, but not like this. They will also have a life of their own. So that is ideal. And I don't think you should be ideal student also like that. Be a real student. It's perfectly fine. Be normal. Yeah? Correct. So that is an ideal cell. Now, once you have understood, what is an ideal cell and what is internal resistance and what is EMF, etc. There are a couple of things which I want you to see. Cells in closed circuit, cells in open circuit versus cells in short circuit. Okay, so let me talk about these three ideas. Now, let me just go over here. See guys, if you take a cell, a real one, of course, this is internal resistance, this is EMF. And now, if the terminals of this cell are connected to some device, any device, okay, this particular device. So that is this one. This is basically connected to a load, connected to a device, resistor. It is a closed circuit. So this first thing is basically you are connecting it to some resistor. This is also called as a load. So this is your closed circuit. Obviously, it is closed because you start from a point and you are able to come back to the same point. So that's why it is called closed. But then, let's say you do not connect only anything. You do not connect anything. So then it is said to be open. You start from a point, you are not able to go to the other point and again keep on coming via the same path. No. So this is basically an open circuit. This is open circuit. But when your circuit is closed and there is no resistance in between, it's just a wire. It's like shorting it. This is called as a short circuit. Short circuit. This is a short circuit. So when you close it, but along that path, there is no resistance. It's shorted. So you will hear this word many times, like there is some resistor here, there is some resistor here, there is some resistor here, there is some resistor here. You want to short these two. Shorting means you are connecting a wire between them. That's it, direct connection. So shorting 2 points means you're connecting a wire. Okay, that is a common terminology which has been used throughout the branch of physics, current, electricity, electronics, electrical, anything. Okay, shorting means you're directly connecting the two. How many of you have just taken a battery? Yeah, how many of you have just taken a battery and connected a wire across them? 100% you would have seen some or the other battery at some point of time and just connected a direct wire from the positive to the negative. Ideally, please don't do that. The moment you do that, there will be a lot of heat which will be generated. The battery will discharge almost within no time. Can you guess why? The battery will discharge almost within no time. Guess why? See, I'll tell you. When you have a closed circuit, what happens is the current will go like this, and this current will be the total voltage by the equivalent resistance, which is R plus R. R plus R. But the moment you have a short circuit, the current which you are expecting to go within this battery is the voltage by this resistance. Usually, this is going to be very, very small. That means this particular current will be very, very large. So what does this tell you about the battery? The cell will discharge very fast because large current has been drawn. The reactions inside the battery will be very quick. That's it. It will be over. All the energy stored will be over within no time. And if you use up all the energy within a short time, heat will be developed in a very short span of time, which otherwise would have been distributed over a long period of time if some external resistance was there. Isn't it? So never ever do that, because if by chance there is some inflammable material inside, that heat, that sudden discharge, surge of current might explode that battery. So please do not do that. Okay, even if it is a simple cell. Okay, great. This is called shorting. So what happens in an open circuit? I mean, like, really, we don't even have to discuss it. Just think about it. What will be the current? The current in the circuit will obviously be zero. No current at all. So there will be no current at all. Wow, that is cool, sir. So there is this concept called, say for example, this was our battery. Sorry. And this is how that battery is. So that internal resistance is a part which is inside the cell. If I measure the voltage across the terminal, the positive and negative, that is called as the terminal voltage of the cell. That voltage, can you see, is also across this resistor R, because this point, same, this point also same. So whatever difference is there here, same over here, parallel circuit like. So voltage across any resistor is the current multiplied by the resistance. Okay, what is the current? Current is this, so it will be E by R plus R multiplied by R. This is one way of doing it. Correct? But I can also see that this particular voltage, okay, I can say it is E minus I into R. And notice why it is also E minus IR, because if I happen to substitute I over here, which is E divided by R plus R, and this is small r. If you do the math, I mean, ER capital, ER small, ER will cancel, we'll get the same thing. So this is the same as saying it is nothing but the terminal voltage is this particular EMF, minus that current which is going in that circuit, into the internal resistance. This is also correct, which means if on the battery it says 1.5 volts, but when you start using the battery and you measure the voltage using a voltmeter, you will never see 1.5 volts, you will see 1.47, 1.48, 1.3, 1.35, like that, always less than that. So the terminal voltage is always less than the EMF. Is this absolutely clear? The terminal voltage is always less than the actual EMF of the cell. Very, very important. If you use that same equation over here, then there is no current. So if somebody happens to measure that same terminal voltage, that V will be equal to E minus current, of course 0, multiplied by the resistance. So 0 into anything is 0 only. So V will be equal to E. This is very, very important, guys. Very, very important equation. Same thing, this one also. So what it means is, when the circuit is open, then the open circuit terminal voltage if there is no current flowing, then it is open circuit, is the EMF of the cell. Very, very important. If the circuit is open, the voltage you measure is exactly EMF. That means if there was no current flowing through this and you measure it using a voltmeter, which is very near to impossible, but if you happen to do that, then whatever voltage you get is exactly the EMF because current is zero. But over here, the terminal voltage, the terminal voltage of a cell is always going to be lesser than the EMF of that cell. Is always going to be lesser than the EMF of the cell. Clear? This also leads to one more thing over here. So I can just get rid of this. If I draw a graph over here, very, very important. I draw a graph over here. Let's say this is our current and let's say this is our terminal voltage. Compare this equation with Y is equal to C plus M into X. C plus X into actually M. Immediately you will be able to understand what is happening over here. Y is like voltage, current is like X, constant is like EMF, and minus R is like the slope or the M. So it will be definitely a straight line. It will definitely be a straight line with a negative slope, something going like this over here. I can put it over here. And yeah, I can start saying that the slope over here, directly you can see it is negative of internal resistance. The intercept over here, wherever it intersects, is the EMF itself. This particular thing, this entire thing where it intersects is the EMF, of course. Yeah, that's all. That's how it goes. Yeah. And if you ask me, what is this over here? Well, can you guess, guys? This particular length? Can you guess what is this particular length going to be? This is the maximum current that can flow in the short circuit. So this is I max during shorting of the circuit, during short circuit, because more than that you cannot take. So when you short the circuit, this is the maximum, largest current that you can get. So that is what this represents. Is this now clear? So this is a very important graph which can actually come. Perfect. Yeah. Very, very important. So I hope you are learning a lot of new things which you would not have traditionally learned in your classrooms or CBSE or whatever, right? Okay. Sir, can we combine these batteries also? Can we group these cells into series and parallel? Definitely. We can group these cells into two particular combinations. We can combine these cells into one single cell in two different combinations. One is parallel and the other one is series. So first let's start with the series grouping. So in the series grouping, when you combine all these cells into one single cell, the equivalent EMF is just E1 plus E2 plus like that till En, and the equivalent internal resistance is simply R1 plus R2 like that till Rn. Very, very straightforward. So this is when it is in series combination. When it is in series combination. Just add the EMFs or add the resistance. That's it. Nothing great. But, sir, what to do if it is parallel grouping? First, let me give you the formula for equivalent internal resistance. It will be just 1 by R1 plus 1 by R2, just like you do it for parallel resistors till 1 by Rn. But be very careful for EMF in parallel. Don't do 1 by E1 plus 1 by E2. That is not correct. The equivalent EMF is, just write the same thing over here. So 1 by R1 plus 1 by R2. How many our batteries are there? It doesn't matter. And here, instead of 1 by R1, put E1 by R1, E2 by R2, and like that till En by Rn. That's it. That is the formula. That is the formula for equivalent EMF. Okay. So these are the two important formulas when you have to group the cells into one single battery. Let me demonstrate this to you via simple example so that you also get a hang of it. Okay. So say for example, I tell you that, hey, listen, we have one battery over here like this and another battery over here like this. And this is, let's say, 6 volts, 2 ohm. Let's say this is 4 volts, 1 ohm. Can you convert this into a single battery? And what if this is connected to, something over here, maybe of 3 ohms or something like that? Okay. So can you find the current in the circuit, etc.? Definitely we can. First of all, this circuit can be narrowed down into a single battery and a single internal resistance connected to this external resistance over here. This is 3 ohm. As you can see, they both are in parallel. So let's find out the equivalent parallel EMF and parallel resistance. First, starting off with parallel internal resistance, it will be 1 by R1 plus 1 by R2. How much it will be? 1 plus 1 by 2 is 3 by 2. So RP will be 2 by 3 ohms. RP will be 2 by 3 ohms. Perfect. What about EP? It is 1 by R1 plus 1 by R2. That means 1 by 1 plus 1 by 2. Here E1 by R1, 4 by 1, 4 by 1 plus E2 by R2. That means 6 by 2. Okay. 4 by 1 is 4. 6 by 2 is 3. 1 plus 1 by 2 is 3 by 2. 4 plus 3 is 7. 7 by 3 and 2 goes on the top. So 14 by 3 volts. So the equivalent EMF is 14 by 3 volts and equivalent internal resistance is 3 by 2 ohms. So we have converted it into a simple circuit. Got it now? How to do these kind of questions? Yeah. Now you can solve this and you can say, oh, this is actually, a single battery only and a single resistance. Now it looks solvable. So this is still 14 by 3 volts, 14 by 3 volts, and this will be 3 plus 3 by 2. So 3 plus 3 by 2, 3 to the 6, 6 plus 3 is 9, so 9 by 2 ohms. Done and dusted. Get it, got it, drama, perfect. Amazing, everyone. Spam, yes, no, fire, thumbs up, smashing the like button, subscribing, do it right away, right now, if you have forgotten. So I'll do one more question, sir. Crazy question, sir. Okay, let's do. Example. There are m rows of n cells of EMF E each. The equivalent cell is what? What is that equivalent cell? This is crazy. There are m rows of n cells each. So if you consider a row, each row has batteries like this, and till the end there are EMFs like this. So this is E, this is R, this is E, this is R, this is E, this is R. Like that, how many cells are there in each row? In the m rows, there are n cells. So there are n number of cells in each row. Okay. Like that, there are many rows. Okay. So if I just consider one of these rows, how much will be the equivalent EMF of that? How much will be the equivalent EMF and equivalent internal resistance? Well, EMF in series, just add them, E plus E plus E, n number of times. So obviously it will be n times of E, and resistance will be R plus R plus R, n number of times. So it will be n times of r. So this will be n times of E, this will be n times of r. This will be n times of E and this will be n times of r. But that is not the overall question. I mean, we still have to solve it. Observe now, what do we do next? Carefully analyze what is happening. There are m such rows. There are m such rows. So like that, there are m number of rows. Each row we just saw is this much. So it is as good as saying, that we have, like this, internal resistance of NR, EMF of N times of E. That's what it is. N times of E, this is N times of R. Is that right? Because each row was a single cell of any EMF and NR internal resistance. Okay. So can I convert this also into a single EMF? Definitely, why not? A single EMF and a single internal resistance. That is what the question is. What is the equivalent cell? Use the parallel resistors formula. That's all. Starting off with what will be 1 by Rp. It will be 1 by Nr. Like that, m number of times, because there are how many rows? There are m number of rows. Do not forget that. M rows are there. So obviously this will be m divided by Nr. So therefore Rp will be Nr divided by m. Equivalent will be Nr by m. So this is Nr divided by m. Cool. How about the EMF? Let's use the formula. EP will be, okay, we have a big thing over here. 1 by R1. R1 is NR. So 1 by R1 plus 1 by R2. Like that, M number of times. Even by R1. So it will be NE by NR. Like that, also again, M number of times. So this is as good as saying NN cancels. It will be E by R multiplied by M. Whole thing divided by 1 by NR multiplied by M. MM cancels, do you notice? So this was nothing but E divided by R, and this was nothing but 1 divided by NR. RR cancels, so this will be E divided by 1 by N, so it will just be N times of E. So N times of E will be just this one. This will be NE. Perfect. Now it is okay. Yeah, this is the right answer. Cool. Everyone. So these kind of questions are also common, where you might be given 2 or 3 or 5, 6 or N or M, whatever, some combination of cells, either series or parallel, and then you have to find the equivalent EMF. So it could be a part of a circuit like one over here. So then you can solve it easily. You don't have to use Kirchhoff's laws or something like that. You can just use it, use the formula of parallel combination or for series combination. Okay, so this is one of the most common techniques for solving these battery questions. Okay, clear guys? Perfect. So that was the last question which we had for today. I hope you. That was the last question for today, my dear warriors. And please solve all the homework questions or whatever questions we have solved in the class as well as practice. And make sure you're attending all the classes over here on the Vedantu NEET English channel. All right. So God bless you all. Have a great night. Do not forget to like the video. You guys might have forgotten. So please do that. And stay subscribed on the #1 NEET English channel, which is the Vedantu NEET English. All right. And by the way, our DNA batch, the Dr. NEET Aspirants batch, the final entry point is there on 31st of July. So make sure you watch it live, all our classes in our batch on a big screen with test series, with mock tests, with DPP's assignment and everything that you need to crack the NEET 2026 examination. Okay. So make the full use of the batch. It's a pure English batch with your favorite teachers out there. Okay. So God bless you all. Bye-bye. Take care. Good night.